Hello and welcome to today's lecture in Computer Tools for Research Communications, and today we will talk about LaTeX. Now, most of you who have read textbooks for scientific subjects in mathematics, physics or other things, you will see there is a particular format in which the texts are written. I mean, by format I mean there is a way to write equations or formulae, or there are ways to write inline mathematical text or symbols. So when you use editing software for writing text, like I don't like to take specific names for its deficiency, but I would say something like MS Word or other software, then we will find that when you see the output, although they are not bad, but they are not quite efficient, at least the way you see in textbooks. So all this business of formatting and writing inline text, editing and cross-referencing, all these things in editing and publishing parlance, they are called typesetting. Now, LaTeX is actually a system for typesetting scientific documents. Now, in LaTeX, by now it's 2019, so it is a quite long history, but it actually started with Donald Knuth, which he himself did it, for he found the deficiencies in the existing software for writing scientific documents, and he himself is a Turing Prize laureate in computer science. So he found there are some deficiencies in the way we write scientific documents in existing software. So he wanted to make a software or typesetting software which is specifically suited for writing scientific texts across various disciplines. So, and there are other people who are involved with it at later point of time, but we'll leave the history for another day, and we'll go a bit of motivation for using LaTeX, because a lot of eminent scientists use it, of course, and a lot of other eminent scientists sometimes still prefer other software, thinking that LaTeX is a way too complicated. You have to think about the subject and then you have to think so much about the typesetting. Sometimes some people will say that perhaps we will not go for it, but we will see in this lecture why LaTeX will always be a better way for document preparation. I mean, except for technical writing, we should also think about some of the other aspects. Now, when you prepare in certain software documents, you go across different systems with different configurations, then you find that there is a problem, because in the way you formatted it, you don't see the output in that particular way. So that is called portability, and portability for LaTeX is a big thing, because it is the output from the LaTeX software after you file the contents is actually platform independent. So there is portability and there is stability. You can see how it arises in connection to portability also. Now, as I said, that there are ways you see books are written, I mean the typesetting aspects. Now, when you see a LaTeX output with significant mathematical content, you will see that how it resembles a book. So it has a very high quality output. Of course, you write your thesis documents also hopefully in LaTeX, but also when you publish, there are specific journals and conferences who actually mention or make it mandatory to write in LaTeX, or in either case, it has its own LaTeX styles that you have to adhere to. So it is important to learn a bit of things in LaTeX. Now, another aspect in LaTeX, some people say that if I have to code for writing texts, then isn't it too much of an effort? But the coding aspect of LaTeX is not that heavy or that difficult, and whatever things you have to learn, especially in terms of commands or notations, you can always go into plenty of those documentation forums over the internet or over book. I will mention some of them in the later lectures. And of course, the error finding and troubleshooting aspect of LaTeX is not that complicated as you see in some of the very sophisticated programming languages. So that makes it much more suitable for people who have not high degree of programming confidence. So in that sense also it is quite usable, and some people who actually believe that it is heavy coding for text are not entirely true. Now we can just have a quick look at the thing, because I mean I have get two expressions, I mean the same expressions in two different software. I will not name the bottom one, but I can say the top one is definitely made in LaTeX, and you can see how well it resembles the things you see in the book. I mean, placing of the integral sign, placing of the limit, the way it writes about functions. So all these things, we'll see it in some detail in later part. Now, as I was talking about references, there are some references online which you can look at to make quick judgment of things, or quick checkup of commands. For that I have mentioned some sites, but there are plenty more if you Google it. But two books which have been accepted by many people as the standard books, one very deep and one good and slightly less involved, I would say. Now, one is called A Guide to LaTeX by H. Kopka, and the other is called LaTeX, a document preparation system. There is something at the end of the slide which I will tell you and where to find that book, but these are the two standard texts which most people use. Now, before we jump deeper into the operations of a LaTeX or a tex file, we will look at some of the basic extensions that is often used in LaTeX, and here we see at the top the .text file, which contains symbol and text written in the editor. In general, the .text file will be the file you will be operating with most while working in LaTeX, because there it will contain all your codes for mathematical symbols, formulae, text, and other illustrations. So .text we will actually operate on. But there are other files you have to look into from time to time in terms of error, compiling, or looking at the details of the output, detailed aspects of the output. So like .aux is for cross-referencing across various LaTeX applications and compilers, and .log will contain the warnings and error message and some such things. I will not list all of them, I will not mention all of them, but most of the important file extensions are listed here. You can check out at your leisure, but it is important to at least know about the basics of them, because at least what they do and how to operate on it, because at times you might need to operate on it. Because look at this example of .lof, okay, which is an auxiliary file that stores the list of figures, or the .lot, which is an auxiliary file that stores the list of tables. So you need to look at those things from time to time. So for that we will maintain a list of files, and which you can look at your leisure. Now, to set up LaTeX for Windows, given a way for Mac users also, but that's not very difficult. These things you actually can look over in the documentation or in forums, you can find that. So you have to install a LaTeX package. Mixtex is often used. That LaTeX package actually installs all the LaTeX resources you need, a PH device driver, and of course you have to install an editor separately on which you will open the tex file and operate on it. So that will go to look at how we create a document using that LaTeX tool. So as I said, the .tex file will be the source LaTeX document. We have to run the LaTeX program, which will generate a DVI file, but sometimes you can change the output to PDF LaTeX and generate a .pdf file directly, the kind of things you see in book, printed version. So you can go through this .dvi, which is device independent output. Actually this .dvi gives LaTeX the platform independence or the portability, as you could say. And then you can, from the DVI or independently, directly using PDF LaTeX, as I said, you can generate the .pdf file as the output, which is your intended output. Now, you will start with a skeletal document, because if you are writing a thesis document, hopefully you have to prepare the skeleton yourself to suit your requirements or your institute's requirements, if there are any. Now, otherwise, while writing research papers in conference and journals, often we will get that skeletal document as an example document from the society or the organization. So you can create it, or you can actually, if you want to try a few things, you can take some formats from the net or from your friends. You can check out on that. You can fill those documents with text, formula, figure, table. So all these things you have, there is a certain way to do it, and you can run the LaTeX program to generate the output and see it. Now, as I will mention at different point of this lecture about the coding aspects, that the familiarity with the LaTeX platform and that tex file. Now, like other times in case of plotting software, or other times I have also mentioned it, for these things you have to code yourself, you have to write your things, and you have to make a few mistakes in order to find some proficiency in it. So as you will find soon that LaTeX, some of the LaTeX commands are quite intuitive, and you know one command with some logical extension, you can yourself find out the other commands. But not only that, once you become proficient in it, you will find that learning new commands are not that difficult in LaTeX. So initially you need a bit of patience, as with any software or any programming language, but ultimately you will be efficient if you code enough in a tex file, compile it, see where you go wrong, or errors. And errors are not that hard to handle, unlike other programming languages. So some very initial commands I will say. Now, one thing I want to distinguish here, it is important to distinguish such things. Now, this is backslash, this is front slash. Sometimes I myself used to get confused to it. So one way to remember is that when you talk about backslash, imagine that the cursor, which was initially this straight, now imagine this cursor as a person. Now, if this is a person, if this person leans backwards, okay, it leans backwards, then it's a backslash. And if leans forward, it's a forward slash. Now in LaTeX, mostly a number of times, I mean, you will have to use this backslash a lot. So, I mean, a lot of the commands actually start with that. I mean, for double backslash actually in LaTeX means space, large space to be given between text or line, but it generally comes at the end of a line. Remember that, because sometimes you will need either of them, and you should not be confused between a backslash and a front slash, because the compiler will generate an error and give you an error. So remember that, because in a lot of applications you need both, and in LaTeX also you sometimes need both. Now use the % command for commanding and ignoring texts. You want it in the text file, but not in the final PDF output. For that, use the % commands. And in general, now in some ways, this is the structure of writing a document. So in general, you will see here you will write. So here will be the command. So he will hit the argument here, and you will use the value. Okay. So something like we might say for some boldface text. Okay. So you can give certain argument for the size, and you can give the value, how much size you want, equal to something. So 0.5. So you can write something. There is an argument here, and the value will be given here. Okay. So in general, this will be the structure also, which will follow in detail, and also in general in LaTeX. Now, in LaTeX, the central such command is document class. That document class actually contains information about the article or the letter or some other such things you are writing. So it will specify whether it's an article, letter, it can specify the font size, like 10 point or 12 point, in that manner, as I said, command, argument, value. Now after that, after you generally write the document class, this is the preamble part of the document. In that you have to install certain user packages that must be loaded already in your system, in that folder where your LaTeX resides. Now that LaTeX will call those packages whenever proper instantiations are required. Like for mathematics, as I said, there are great many ways of writing mathematics in LaTeX. Now for that you have to import certain user packages which will interpret the command as such in between texts. Now often I'll list the packages later. I'm not going in detail about packages, because which package to use, at least which important packages to know about for writing in LaTeX. I'll list a few of them. And of course you can define your new environments or new commands with the new command command. Okay. So I said already about BF for boldface, for italics you can use as IT or some other things. Now this basic structure of a LaTeX document generally looks like this. I was saying about the document class. You see here we are talking about the document class with 12 point. It talks about a font of 12 point size throughout the document unless otherwise specified, and it's in the article format. So this is part of the preamble. Now, along with the user packages, there can be many more user packages. We have seen color and graphics. Now this color is for using various colors in the document that you are using, and this graphics actually handles GRAPHICX. It's actually called graphics. Now this graphics user package actually handles images and other aspects related to image size, images, captioning, labeling. All these things are handled by this graphics package. So if you are using any illustrations, you have to import this package. So like this we write very basic stuff. Now sometimes you need to write the title and author information, a lot of the times, but often in the research documents you have to write that. Now this is the way to write the title and author names and any acknowledgement that you want to give to certain body or a person which has certain contribution to your research, which is required to be acknowledged, but not so much that can warrant an authorship. In such cases you write your acknowledgements. Often you acknowledge the funding bodies in case of a big project that you executed and got the results to write a paper. In that case you thank such funding agencies. So you use those things to say certain things about the document which is not technical but still gives the required information. Now introduction is a part of most documents, and this is the command to write any section, not only introduction in general, that /section, \section. And you see, as I said, this section is the command, and it talks about particular argument, and that is introduction. So you will have a section titled introduction. In that you can write subsections, and you can write further subsections by adding sub. So subsection will give you another subsection in the tree structure under introduction. Now we will look at some of the code and output aspects of what we spoke till now. So you see document class article, we are writing the begin document, end document, under this everything will be there, and we generate this output as a PDF output. And if you go a little further, you will see certain ways of generating much more. We have the title, article, and then we specify introductions and experiment as the subsection of the introduction, which you not generally do it that way, but it is the way we are trying to show you that how it works. Coming to symbols and notations, a lot of the things about symbols and notations, I mean there are plenty of them in the list. You will get a number of lists in net or other forums that they are giving a full range of possible symbols, not only mathematical but other possible symbols also. But in very basic cases, you can actually think about the commands on your own without really looking at the documentations if you know some of the basic ones. I will give you an example of, suppose the way to write theta in LaTeX is, so you write this, right. So you can naturally conclude that for alpha you have this, right. We need this capital letter commands for the capital Greek alphabets. We are talking about Greek alphabets in this particular case. Now if we have pi, we go to pi, right, and then if we write pi, it will generate something like this. Okay, so that's quite intuitive. I mean, you can have your logical extensions to figure out that how it works. So for, I mean, phi also, so you write phi, you give phi, and then phi gives you something like this. Okay, so I mean, and other symbols also. We are talking about mathematical symbols and letters, but we can talk about operators also in the same vein, and they are often very easy to figure out. Like, I will give you an example here that it's so okay, this is for union and intersections, as you can figure out from the symbols, and these are the way to write them. So there are plenty of them. I mean, it is no point going on listing about them, but I am trying to show you some of the logical ways you can figure out commands once you get quite conversant with the LaTeX tools and in general document preparation in LaTeX. So there are plenty of such symbols which I have mentioned here. You can look at it whenever you require, but there are many others which you will find in these repositories. I mean, they are quite good, and they are generally, whatever editor you use, it does not matter, they are quite uniform across editors. Now I was talking about math. Now when you write equations, you have other ways of writing equations specifically highlighted in the text, separate from the text. But in a lot of the times, we have to use inline mathematical text. So for that, the most simple way to do it is actually $. So if you write theta, you will get theta in the inline text. So you can write something text here, you can write some text here, you will get the text here, and in between you will get theta. Now except working with that, I mean, we have said other things are also possible, like this in the first bracket format, or sometimes this. These are also ways of writing inline text. But I occasionally prefer $, because you have to write less symbol. I mean, you have to type 4 here, you have to type 2 there. So I sometimes prefer $, mostly I prefer $, but you can use the other ones also, the equivalent. Sometimes while you are writing mathematics inline in text, but in the mathematics itself you have to write text. For this you can use mbox in a very same ways. That is, you write the mathematical formulas, perhaps, I mean, in $, you have the mathematical formula, then you use mbox to write a bit of text. Okay, if something, so if you want to write, if something greater than 0, that's a condition, so you want to write if, you will perhaps write if here. Okay, not this way, so second bracket, so then the mathematics, and then dollar. So this will give first mathematics in text, then text within the mathematical symbols. So you would often need to use this when you are writing a mathematical document. Begin document, end document contains everything that you will write, and it's an environment, document environment. Similarly, you can define smaller environments within that begin document, end document, and it is that environment actually contains specific ways of writing the way you want to write. It contains some specific ways. Suppose I have to itemize certain things, in that I want to make a list, okay? Or perhaps I want to write a theorem. So in that, if I write theorem in place of environment name, and in both the snippets, that is begin theorem, the detail of the theorem, end theorem, it will generate a theorem environment. Similarly, if you write itemize, it will generate a list of the given items. In that case, for itemizing, you have to write separately that item and the item name. You have to give a list in that way. So you can see we have the standard environments for a lot of things, and not only theorems, and we can have standard environments for proofs, for propositions, okay, and corollaries. So you can slowly learn all of them. We will not mention everything in one lecture, but generating these environments is not very difficult. And sometimes if that environment is not available in a particular LaTeX style, then you of course can create your new environment using the new command that we mentioned at the beginning of this demonstration, that you can use new command also to generate certain other environments which is not originally given in the class files. Often in your LaTeX document, you have to generate numbers in a sequential manner to reference or access theorems, equations, figures, or particular sections, which you generally call cross-referencing in the parlance of publications. Now, this cross-referencing has a particular method that have been mentioned in the lecture. I mean, this is the very basic way of referencing. For that, you don't need to, I don't think you need to import any package for that, okay? But there are certain other ways of referencing for which you have to import specific packages which contain certain ways of referencing. But this is the most general, where you will write the section, below the section you will give a label to it, which is written by this, that label. Sometimes in case of figures, it is better, figures or sections, it's better to write in this way. That I'll give you an example. Suppose you are writing a figure somewhere. I mean, you want to place a figure somehow, okay? So you write this. Okay. In figure. Now, for this I said that you have to import the graphics user package somewhere at the preamble. So I hope that is done, otherwise that will give an error. So import graphics you have to write somewhere in the preamble. Now if you are writing this figure here, you will mention the figure properties, right? Width, height, caption, all these things. Now after you mention all of them, you will write a small label, right? You will write a small label, and you will give the figure name according to the content or the type of thing it tries to emphasize. It is always a good practice to write the figure name like this, okay? Figure column, figure name. There is a reason for that. Now that figure name in explicit format, or the section name, okay, or the theorem name explicitly, you might use it elsewhere, but in that place you don't want to cite it. You want to cite it in a particular place in text, where you will write in some particular text, where perhaps below it or perhaps in the vicinity of this, you will write some text where you want to cite this particular figure. So in that you will write #ref /ref, and then you will write the. So if you write that, then when you compile the output in the PDF, it generates a number. Okay. That number is sequential in terms of how many figures you had, or how many theorems you have written, or how many sections you have. So that sequential number will appear then there, hopefully with a hyperlink, and on which you can click, it will take you back to the figure. So that's why it's called cross-referencing. So you can cross-reference, which is for your benefit and also for the benefit of the reader or the reviewer who is reading your paper or document. But the structure of cross-referencing is actually same for introductions, figures, or theorems, or other environments that you could create, because that's the general structure of the code snippet. You have to put the actual thing as need be. Now, because talking about these environments, we should talk about user packages and new commands a little bit. Now, you should not load your LaTeX with too many packages in advance, because you can work on it, you can get stuck with certain things, you feel certain things need to be expressed in a better way, and you don't have the tools right now in your LaTeX repository. Then you can search for the packages which does the job and install it. So you can install it on the fly as you get the need for it. Don't install too many packages at the beginning, because when it compiles, every time it has to look for that, whether it is there or not. So it takes a bit more time. So do not load with unnecessary packages. But of course, install them, which are useful for neat and elegant description of your content. Sometimes you can use multi-column for lengthy arrays. For that, you have to install separate packages. Sometimes you need specific symbols. It happens often in set theory or abstract algebra that you have to use certain notations which are not very generic, rather specific. So for that, you need sometimes a better package than generally the ones we used in AMS math or other ones. But in that case, you have to install certain extra packages. But that is not a big problem, because again, you can go to the forums and documentations, and you can search that which particular package will contain that symbol in command form, and you can get to know about that and you can use it. But it is good to have an idea about what the package contains in general before really using it, because certain other packages have conflicts. If you have two different bibliography or citation packages, they often generate conflict in citation, and compiler will give you a warning or an error message. So that's for user packages, and some journal class files will actually mention you some advanced user packages to use in specific cases. So for that cases, you don't need to worry about which package to use. Now in new commands, I will not mention the code separately, because you can see the structure here. Okay, so it will have the new command with that name of the command. So if you are adding a corollary, so you can say corollary, a number, and you can give the definition also. If you see, I have given an example here. It's a definition for this mod sign, mod sign, okay, mod x, our favorite graph, y equal to mod x. So I mean, it is possible. In fact, if you have shift and backslash, you get something like mod. I mean, if you hit shift plus backslash twice, you get something of a mod sign, I mean, which is slightly weaker than the mod sign that we know. But this is a way to generate a proper mod sign with a new command, even if you don't find the symbol in your AMS map package. But I think now AMS symbol contains certain other commands. But even if you don't have a command, you can use it. Okay, so user packages. I mean, there are plenty of user packages that we can talk about, and we will not have the time, because that will contain a separate lecture in itself. But I will mention some of them which I have find very useful. Of course, there are citation and bibliography packages which I have not mentioned here, but for the working of the main content, okay, in especially scientific communication, technical research writing, these are the packages you will find very important, and almost in a lot of the cases you have to use them. Okay, so I have spoken about graphics and other packages already. This EPS to PDF helps in EPS to PDF conversion, or vice versa. So sometimes somebody needs this in EPS format, the images and the illustrations, that is mandatory in some cases. So you need that. Now subfigure is a very useful package, because it is, of course, you can figure out it's about grouping and other aspects of figures. Now in a lot of cases, especially in double column formats and a lot of the times in single column format, you will have a problem with grouping of your figures if your results or your illustration contains in figure in such a way that has 8 to 10 figures in a particular order, that actually not only tells you a particular result, it actually tells you a story. So those 8, 10 results, the order, the sequence has to be maintained. and also they can have bigger captions and labels, bigger captions about the images. So the space management is also an issue. I mean, in general, you will find in LaTeX, in connection to images, space management is an issue, because I think LaTeX has this command of exclamation HTB, which kind of forces an image to be placed in a specific place. Here HTB stands for here top below. Yeah. So according to where you, it kind of enforces, because otherwise LaTeX tries to decide in its own way to move around spaces for images as it suits for it. Now, subfigure by grouping of figures help you to manage also in terms of managing the space for figures. So that is why it is also very important that you use subfigure packages. You can use comments, and for comments and margins, I said about MS Math, and MS Symbol is another advanced package for mathematical symbols. For writing algorithms, now if you see in books or other demonstrations or other technical documents, there is a specific way of writing algorithms, right? I mean, something you write a data, right? You write the output, okay? Then you write snippets of code here, that goes on here. There is a bit of if, else, if, else. Okay, so this kind of nesting is there, okay? So this kind of structure is there, right, in algorithms. So when you have this kind of a structure, you generally don't generate such structural diagrams very easily. So for that, you have to install certain user packages, something like algorithm 2E or algorithmix. I think algorithmix is the old one, and algorithm 2E has some new facilities in terms of loop writing or do while and fors, certain other innovations. But both of them are equally good. You cannot really choose between one and the other. But you might sometimes have a particular journal requirement to use that particular package for algorithms. So you have to be careful about that. I will not go in detail about writing equations here, because you have to use this begin equation and end equation environment. And this kind of environment I have spoken about in this lecture, and the symbols. So this is generally the way you can look at the snippet at your own leisure. And you can see how you do the operators. Here you see sqrt gives the square root here somewhere. Yeah, hash frac generates a particular way. Sometimes a lot of people tend to write fraction in mathematics like this, a by b. Well, that is okay. Otherwise, you can write always like this. So that gives you a proper. That is right. So similar some such commands are there. You can always have a look. Images, I already spoke about how to write the begin figure and figure environment. In that you have this, when you install that user graphics package, you have these other options of centering. So that centers the image within the space that is reserved for the image, and the name of the image file stored in the local folder. You have to give the path name correctly. Often it might happen that the path name is not correct and it is not being compiled. So the path name should be correct. And it is often easier if you have the things in the same folder. So then you don't need to give a big path name. You can always just mention the file name. And this is how you incorporate a figure. You see user package graphics, you have the begin documents, you have given a level, figure 1, and there's the figure you have, it's the width of 80% of the size, and when you go next, you see we have increased it to a particular size, and hopefully you kind of recognize the image, right? I hope so. It's Sistine Chapel, the ceiling painted by Michelangelo, that's the one. Now, I'm not really giving a detail of these codes by at least an explanation, because some of them I have given, and you can always look at it and perhaps try a code of your own to figure out how it works. Now, image is a float object, right? That LaTeX actually pushes around things to make way for image, and it generally tries to choose on its own what we should use. So that's why I have said that you need to use this here top below command with an exclamation to enforce the space constraint on the LaTeX software. You can use the subfigure packages for efficient space management. I mean, by grouping of pictures, actually you manage the space given to you efficiently, so that is important. And generally it is EPS a lot of people use, but .jpg in a very generic way I can say that .jpg is good because it takes less space in the LaTeX file, not only in the folder. So it's good to use them, and some people actually don't accept things without JPG or EPS way. And as I said, we have to adhere to the artwork guideline of the journal, because certain things, although it is permitted in terms of LaTeX commands or LaTeX environment, it may not be permitted in the context of the journal publishing style. Okay, so this is one way of creating a table. You see that we again declare an environment to separate it in text, which is a table environment, begin table and table, which is embedded in another environment, that is begin document and end document. And if you see, we want to minimize the space for writing the code. So all those user packages, if you are not using too many, then you can actually use it in one line of command by separating the user packages by a comma. You see this user package EPS fig and graphics. So we have put them together, that actually installs both the user packages. And if you have too many of them, it's kind of awkward to write in by comma separated way. Okay, so here is the way to write a label and how to do a cross referencing. Okay, so here you see we have given a label to this introduction. Of course, that will not appear in the text, it's a part of the code. Here we see the introduction title, and some text will be there, and in the next section or somewhere we give a reference to that, and for that we use this #ref intro. Although I would say that we should have written sec:*intro, here it is okay, but generally that's the way. Now we have mentioned in various contexts in this lecture series that citation is important, and this is the way to cite. Now a lot of journals will have their own bibliography styles, and you must adhere to that. And we are not specifying here what bibliography style you should include, but you should include one, and you should follow that particular style consistently, because that bibliography is a serious requirement, and we have mentioned this in literature review and other lectures, that review is citing others' works is important. So we will cite it in this way. We will not explain the code, because again we have these two ways of writing it. You can give this bibliography list in the paper text itself in the .text file, or you can write a separate bibliography file for the citations that we will use, and you can include those bibliography files by a single line command by just mentioning the style sheet for the bibliography where you have put them. So you see, this is the way we write. Now we have mentioned this bibliography environment, right, for bibliography and reference list, but now that contains the references, but you have to give a set of well sequenced, well grouped numbers to identify them in the text, so that in text we will write certain text here. I have shown an example of the running of only 2 references here, but we generally include much more than that, and it also includes that the 2 books I was talking about in the beginning, right, H. Kopka, A Guide to LaTeX, okay, the edition you can think of for if you want to buy or refer. I think there are some recent editions also, and the famous one, more famous one, I think, the Leslie Lamport, A Document Preparation Systems in LaTeX, which is an extensive book on LaTeX. Okay, so you can use 2 of them. Okay, so as I mentioned here, I told you just time before that you can use 1 or 2 keys or 3 keys together, or you can use each of them separately. So sometimes you can have a listing like this, which gives 1, 2, 3 to 5. So that's what I mentioned by grouping keys together in text. So sometimes you can have that kind of a citation, or the other one I showed, that each citation is a separate space and has a separate entity. So sometimes you want to group your literature in a particular way, then you often cite like this. So you cluster one particular work and give the corresponding citations in one place. So sometimes you can cite also in this way. Now this is an example document from an IEEE journal. I will not go through it in detail, which tells you how a text file looks like when you actually work in professional environments, how it looks like. It will be much bigger than this, but I will just give you a bigger snippet on from the original document. And now in general I will tell you that you have to write and code as much as possible, because initially you will find the environment slightly tricky because you are not conversant with it, but as you go along you code, by the time you kind of write 2 papers or 2 documents, you will be more proficient with it, and you will learn the tricks and trades of the business, that there is always a forum or convenient place to look for a command which suits your case, but you don't yet know it. So, I mean, I wish you a good LaTeX experience in the future, and with that we end this lecture. Any questions?
So I have 4 questions for you. The first question is that if I am writing a very long document, how can I break that, for example, into chapters and to maintain the same format throughout? Second question is for referencing in the bibliography, I had a problem that when I have used that reference in the text, it appears, and in the reference list also appears, but when I click on the numbers, it does not go back into the means it does not go into the reference which I am actually pointing. So how to fix this problem? The third question is for a beginner, how to actually understand the errors that come, means how to read and understand the errors and try to figure out that what the error is. And the last question is if LaTeX can be used for making presentations, and if yes, then on which case we should prefer using it over MS PowerPoint.
Go back the reverse order, okay? The more recent question first. So, you know, for making presentations, you have to use LaTeX Beamer class. You have heard about LaTeX Beamer class? Okay. So, yeah, I mean, if you ask me personally that which one is better, there is no definite answer to it, but LaTeX Beamer class gives you more facilities in terms of for technical presentations, and it has a lot of other facilities also in terms of, you know, what Microsoft PowerPoint is good at in terms of, you know, a lot of decorations and a lot of other innovations. But it is, as it is LaTeX, it has got certain technical facilities, so Beamer class is good to use. When it is good to use over MS PowerPoint, that's a very, well, it depends on individual taste, let me say that. Okay, there is no definite borderline, but if one knows both, and there is a presentation which is, you know, mathematically heavy in terms of a lot of symbols and notations, perhaps I would suggest that in that case you should go for the Beamer class, which integrates all PowerPoint presentations or that style of innovations or you know, styling capabilities, but it has this technical sophisticacy of representing mathematics. So yeah, that is one. So what was the third question? Errors, understanding errors. First of all, understanding those errors are not for beginners. I think you said that whether beginners are, I mean, how do we understand that? You know that the compiler of C was written in C language, but it's always not so that when you read the error log, I mean error messages, and the way you code and the way they interpret are not same. Now when it is not same, one way to know about it is reading about the LaTeX error messages in documentation and forums, but in the beginning I will tell you not to waste too many times in that, okay? Because in the beginning it is more important for you to learn how to do your thing, that for which actually you try to use LaTeX. So, but as you go along and you find these errors and you correct it, you actually understand that how these error messages are related to the actual error you are making. So slowly you understand. And the other thing I want to tell you, that it is in a large number of cases it is possible to fix those errors without really understanding the LaTeX message. That's actually another, I think, a powerful way. You know, if you are not a very coding savvy guy, because when you are really in hurry to submit a document, okay, you have this 124-hour deadline left, you don't want to spend your time understanding all the error logs at that point of time itself, all of them. So I believe you should try to, because there is a line number, right, that you can go, and if your coding syntax skills, okay, then you will understand where you have gone wrong, and you can understand that. Very simple errors are like missing dollar, right? You have seen this kind of errors, missing second bracket, okay, this thing, or the compiler could not identify, or in case of double slash, I sometimes found this error that there is no line to end here. Have you ever found this message? There is no line to end here, because it tells you that I cannot give you so much space space, because actually the error it comes in such a form that it tells you that I cannot afford to do such a space because you are still continuing a line, it is not a new paragraph or anything, okay. So there is no line here to end. So in that language it comes, but I don't think you need to always learn that error logs in with a lot of heart, because that will come to you. More important is to get the operational aspects. That's it. Second question was this, I remember that how to connect the references, right? Now I have shown, but you are talking about the error. There are two things I want to tell you. First, suppose your references are fine. Now you have got some error messages or some other errors in other aspects of the document or other sections. So you have to correct that error, recompile it, and now when you run, in the first 2-3 times it often happens the references don't come, the hyperlinks. Often you get the question mark in place of those hyperlinks. So it happens because when it again interprets the document, so after you correct the error, it recompiles, it starts afresh, writes out the log file. It initially does not recognize the bibliographic connections. So that's why you get the error. Sometimes it happens the symbols appear and your problem that you said that doesn't go to there. So I will tell you in references sometimes you have to, for sure after generating the document you have to compile it or recompile it 10 times or 12 times. I mean I have had the 5-6 times it was not coming, it happened. The other kind of thing it happens, some particular LaTeX class file has this funny way, I will tell you, that it actually comes a lot of the times, but not in proper places, is a subjective statement. I will give you an example. This is your image. Here you have the caption, which talks about the figure, and here is your image number. Am I correct? That's what you get. Actually every time it goes below this image number, that hyperlink, in a lot of class files. So it might happen, it is still coming, but I mean the way your system is, you actually see this image number, not these images, but when you scroll up you see the images. So you are getting pointed to the image number correctly. So in terms of that there is no error. But it is an error, it is not an error, it is a subjective thing that it actually points you to the image number, you have to look for that image number. Sometimes you are looking for the image in connection to this number, but it actually points to the image number which is below the image, and in case of big images it is quite below, so you actually have to scroll upward to find it. It is a problem with some class files I have found, but some class files will give you directly to the image. So this is not a, I think this is a very specific case, not a very general case. And now coming back to your first question, chapters and writing styles in general. Long documents, because we are mostly talking about thesis documents, I hope, because in journals you don't have that problem, or conferences, because you have the styles. Now there are other things like chapters or paragraphs or set lengths. You have these commands, right? That increases new chapters and new things, so that is fine. In terms of long document styling, it depends what kind of work you are doing. Like if it's a very mathematical work, you should import those kind of user packages and graphics packages. First of all, you have to have a clear picture of what kind of style you want. Then you have to look for user packages and styling aspects that suits your requirement, not the other way around. A lot of beginners make this mistake of collecting a lot of user packages, and whatever they have, from that they try to write it, and then in between they will get stuck, and then they will try how to use this, how to use that. But as I said in the lecture also, that in certain cases you will have this conflict, because there are 2-3 good packages for the same idea, and if you install all of them, it will conflict in the styling things. So you have to be careful for one purpose, one package. Only a second package when you are confirmed that it doesn't have a conflict with the first package in the same category. So that is an important thing. But otherwise, it is the same as writing any documents in journals. But you have to be more careful about the consistency in formatting and typesetting in terms of a long document or a thesis. That is the only problem, but it is more about meticulousness of the individual also than anything specific in LaTeX. Okay? Thank you. Any other question? Okay? Thank you.